Welcome back. So in last lectures, I mentioned that whenever we get alkyls that they have 3 or more carbons, we might actually get different structures. Why different structure? Because you will have hydrogens that they are not identical. And it depends which one you remove, the name will be different or the structure will be different. And I put a star on, those actually on those compounds like a propyl, butyl, pentyl, or hexyl, and we're gonna try to go after them. Okay, so we are trying to learn how to name any in the alkane. We said we need to know the biggest chain, and that's gonna be the parent. Next, we need to know the substituent. What's the name of the substituent, and where are they? Okay. And so I'm going to start with propane. Propane has 3 carbons, and 2 of them are terminal. They have 3 hydrogens, and one in the middle. Okay, the one in the middle is different than the terminal's hydrogen. Okay, so what will happen if I remove one of the terminals? So let's say we're going to go after one of this hydrogen, and I'm going to say I'm going to go after the hydrogen, for instance. And if I do it, like, and say minus hydrogen, the structure that I'm going to get, it will be like this. This is going to be the structure. Okay, so we get this alkyl, and that alkyl must be attached to somewhere. Okay, and I'm going to say the alkyl is attached to the main chain or the parent. Okay, the parent. This substituent, we call it, okay, we call it N pro Y prop, because you have 3 carbons, and then you say N propyl, YL, because you want to say is attached to the parent. Okay, what's the purpose of N? The N is just to say this is linear. Okay, linear shape, and yes, it's linear, 3 carbons right after each other. What's the symbol for it? Okay, and it's kind of like is all the style this day. Just simply they say, propyl, go with a propyl, and that's fine, and go with a propyl, and the symbol it will be PR. Okay, but there is a way like an IPAC system to name it, and the IPAC system says start from the carbon that's attached to the parent and label the carbons. And I'm going to say I see 1, 2, 3 carbons. Okay, because I see 3 carbons, so the name is going to be this. The IPAC name, it will be pro Y prop, because I want to say I have 3 carbons. N is attached to the parent. How do I say attached? I put YL. Okay, and then I will name. Okay, I will name. Okay, here after this one, you will say name of the parent. Okay, so the symbol, it will be propyl. Okay, I'm just gonna get rid of this. Okay, this is gonna be the technically the correct way to name it based on IPAC system. Okay, another one. Okay, can I remove 1 hydrogen, for example, from the second carbon? Yes, if you remove it, this is gonna be the geometry that or structure that you will get. Okay, so the carbon in the middle, it will be attached to the parent. Okay, and this piece is going to be your substituent. Name for that one, okay, the common name for it, okay, we call it iso. Okay, iso propyl. Okay, that's the common name for it. And the IPAC name, IPAC, again, this is the starter from the carbon that attached to the parent, and this is going to be the carbon that attached to the parent, 1, 2. So I have 2 carbons, okay, starting from the one that attached to the parent. I have 2 carbons there, and so I'm going to say on the first carbon, I see a methyl group. Okay, which methyl? This is the one I'm talking about it. I see a methyl attached to 2 carbons, technically. So what do we have? We have a methyl group attached to 2 carbons. We're going to say on the first carbon, okay, we have methyl. Methyl attached to what? Attached to 2 carbons, those 2 that I highlighted. And in order to say 2 carbons, you say ethyl. Why ethyl? Why YL? Because you want to say the YL, like entire of this piece, 1 methyl. Ethyl is attached to the parent. okay, attached to the parent. Okay, so that's the reason 2 times I'm using YL. The first YL is saying methyl is attached to the ethyl. And the second Y is saying entire of this piece is attached to the parent. Okay, and that's the reason I'm using 2 YL. Okay, and this is the IPAC way actually to name the substituent. Okay, so we got 2 of them. Let's show them. Okay, for propyl, we have 1 is linear. So I go 1, 2. Okay, so we have 3 carbons. We had 1 hydrogen here. Okay, if I remove 1 hydrogen from it, minus hydrogen, this is the structure that I get. And what do I have here? I will have the parent. Okay, if you get such a structure, this one we call it propyl. Okay, but if you go with stuff like, for example, this, okay, and you have hydrogen, the one carbon that is in the middle, and you remove hydrogen from it, so you go minus H, and that's going to give you such a shape. It will be like a V shape, and the parent, it will be attached there. The V shape, I'm going to highlight it. The V shape, we call it isopropyl. Okay, isopropyl. Okay, so we got 2 structures for technically propyl. You can say 2 isomers. Okay, how about like a butyl? What will happen if you have 4 carbons? If you have 4 carbons, in that case, okay, you need to be careful, because you can for butyl, for butane, you have 2 isomers, and the first isomer is linear, and as you see, I have 2 terminal carbons and 2 in the middle. Okay, so those 2 pinkish or reddish, hydrogens are the same. Sorry, they have the technique. Yes, they are identical. You can say they are the same, and also the terminals identical. And this is the way we represent them. So we say 1, forgive me. Okay, I go zigzag, and okay, each actually corner is represent 1 carbon. So totally I have 4 carbons. Okay, why zigzag? Because I'm trying to keep the bond angle somewhere around 109.5, because it's tetrahedral. Okay. Now, if I remove 1 hydrogen from the terminal actually carbons, then I get this. Okay, say we decided to remove this hydrogen, and if we remove that hydrogen structure that we get, it will be like this. And the parent will be attached here. So we're going to say parent will be attached there. This piece, okay, you can call it N-butyl, N-butyl, or just simply butyl. Okay, and what's the symbol for it? Bu. Okay, Bu, it will be the symbol for it. Okay, let me move them a bit that side. So you can say here, butyl. Okay, I put dash line just to show that they are attached to somewhere else. Okay, or how about this? Okay, can I take 1 hydrogen from, for example, any of those, reddish or pinkish, hydrogen? Yes, we can go after one of them, and so say, okay, we're gonna remove one of them, like one of these hydrogen atoms. So I have this structure. Okay, and I'm going after this hydrogen. Okay, let's remove that hydrogen. If we remove that hydrogen, this is the structure that we're going to get. So minus H, and I get this. Instead of the H, I will have the parent. Okay. Parent, And this one, this one is attached to the second carbon. Because it's attached to the second carbon, we call it, secondary butyl. Okay, secondary butyl. Why? Because again, attached to the second carbon. Okay, there are some ways, to name them, like IUPAC way to name them, and I want, to present actually those names. So if I go with the IUPAC name says starting from the carbon that attached to the parent and label them. You go 1, 2, 3, 4. We have 4 carbons attached to the parent. So this is going to be, technically, it's going to be just simply butyl. Okay, that's going to be the IUPAC name for it. Okay, and the butyl is attached to the parent. Okay, how about this? And this one says highlight the longest chain. The longest chain is starting from the carbon that attached to the parent. So this is going to be your 1, and then you say 2, 3. Be careful, okay? Be careful, because we started labeling from the carbon that attached to the parent. And so we're going to say this is going to be our longest chain. Okay, and we do have a substituent attached to it. That's our substituent. Our substituent, it will be methyl. Okay, methyl group, which is attached to what? To 3 carbons. So what's the name for it? The name for it, it will be this. On the first carbon, we have a methyl. Okay, methyl attached to what? Attached to 3 carbons. And because we have 3 carbons, so we're going to say propyl. Forgive me. Propyl. Okay, I prefer to use a blue for it. Propyl. So 1-methyl. Okay, propyl. That means you want to say that the 1-methyl is attached to the propyl. Okay, on which carbon of the propyl? On the first carbon of the propyl. So this one, the one I used here, is to represent that, the methyl is sitting on that carbon. Okay, another isomer for butyl, okay, is, so for butane, we said we can have linear, which is equal to this structure. Okay, that's going to be the linear geometry. Or, okay, you can have this. Move one of the carbon and attach it to like one of the central carbons. And so your longest chain, in this case, it will have only 3 carbons. Okay, and you do have one substituent. So in this case, we're going to say we have 3 carbons. And there is carbon also attached to it. Okay, now this is going to be the second, isomer for technically for methane. Forgive me, for butane. Okay, and you need to be careful about the hydrogens that you are dealing with. So let's go after this and present all possible isomers for it technically. Okay, now this is equal to CH3 attached to carbon, that carbon attached to CH3. Okay, and down here we have another CH3. But the central one is not octet. How do you make it octet? You need to have 1 hydrogen attached to it. So we have 1 hydrogen there. Okay, now it depends which hydrogen you pick. You might get different, technically, structures. Okay, so let's label them. Yellows are identical. And we have 1 here. Okay, let's remove one of the yellows. Okay, if we remove one of the yellows, we're going to get this. We're going to get, okay, so we have, okay, hydrogen attached to one of the yellows positions. Okay, and we remove that hydrogen, and if we remove it, we get such a structure. And remember, parent will be attached there. So now what should I call this? Okay, what should I call it? Let's see. Okay, I see. Okay, see 1, 2, 3. Okay, and 3. And I have a methyl group there. Okay, and if you highlight this side, okay, you get like kind of like a V shape, and or okay, just to make it easier for you to visualize it. Okay, let's go back for a second. Instead of removing that hydrogen, okay, say you decided to remove one hydrogen that attached here, one hydrogen attached there. Okay, again, I told you those are identical. Those hydrogen are identical. So let's remove one hydrogen from there. And if we do it, we get this. The parent will be attached there. Okay, what should I call this piece? What should I call it? Okay, let's check it. We got a V shape here that attached to one carbon. Okay, we got a V shape that attached to one carbon. And the common name for it is gonna be iso. Okay, because I have 4 carbon, it will be isobutyl. That's a common name for it. Okay, what's the IUPAC name for it? 1, 2, 3. You have a methyl group there. Okay, so the IUPAC name for it, it will be this. Okay, it will be on the second carbon, I have a methyl group. So I'm going to say methyl. Okay, attached to where? Attached to 3 carbons. So, okay, this is going to be the 3 carbons here, attached to 3 carbons. And I'm going to say name for the parent, like technically the 3 carbons, it will be propyl. Okay, 2-methyl sitting on propyl, and the propyl is sitting on parent. Okay, that's one, isomer. Okay, one isomer for the second structure. And also you have a hydrogen here. You have hydrogen, red hydrogen. What will happen if you remove that hydrogen? And if you remove that hydrogen, you get this. So you have carbon that attached to 3 carbons. And there is hydrogen here. Remember, those are CH3. Okay, if I remove H from it, I get this. I get carbon attached to carbons. Okay, and this one, it will be attached to parent. Okay, what's the name for this one? Name for it, the common name for it is tert. Butyl. Okay, tert butyl. That's a common name for them. What's the IUPAC name for it? You start from the first carbon. You go 1, 2. Okay, you have 2 carbons there. Okay, so let's highlight them. How many substituents are attached to them? 2 of them. And where are they? On the first carbon. So on the first carbon, on the first carbon, on the first carbon, 1. Okay, and another one. Why 1? Because I have 2 methyls, 1 and 1. Okay, they are sitting on the first carbon. And in order to say I have 2, I say di. Okay, dimethyl. That means I have 2 carbons. And where are they? They are sitting on 2 carbons, and it will be ethyl. Okay, this piece is sitting on the ethyl. Okay, and that's another way actually to name like the tert butyl. Okay, let me write one here, like give you one hint about the iso, how to remember them. Okay, start with this. You have a V shape. Okay, how many carbons do you see? I see 3 of them. Okay, and then you will draw line and you say they are attached to parent. Okay, the one I'm going to highlight, because it's a V shape, it will be iso. Okay, next, how many carbon we have? 3. Propyl. Okay, let's repeat this one. Okay, 3, and we're going to add 1, 4, and this is going to be again here. We will attach it to parent. Now I have V shape and 1 more carbon, and that's 1 more carbon. Okay, so I'm going to say this is going to be iso, but because I have 4 carbon, it will be butyl. Okay, another one. Okay, let's go after V shape. Okay, we add 1 carbon, 1 more carbon, and now we're going to draw line that attached to the parent. So now I have 3 carbons there, V shape, and I got two more here. Okay, so I have 5 carbons. This is going to be isopentyl. Okay. And as you see, the common things between V shape, between iso is the V shape. Thank you very much, and I will see you very soon.